Hello everyone. I'm glad to teach you this course. I'm happy for the new course. It's college algebra, and as you know, my name is Dilan, and this is a summer course. It's a short course for you. In general, we are going to talk about college algebra, which is really is an intensive course, and there's a lot of information and many concepts that you need to get the idea about it. First, it's not difficult, but you need more really time. You should, if you have a good background in math, it's okay. Otherwise, you need more time to control this course in general. First of all, in this chapter 1, we have a 6 section, and gradually, step by step, I am going to clarify for you each sentence and each equation that you need. In the first page in the first section, chapter 1, section 1, we are going to talk about in general real numbers and the other numbers. In general, in mathematics, we have a natural number which contains the set of 1, 2, 3, and go on. That's the general case. Contains the positive numbers. Also, we have the natural. Also, we have integer numbers which containing, for example, many numbers like a -2, -1, 0, 1, 2, and go on. It's integers. And also after the integer numbers, we have rational numbers which contain numbers like -1/2, for example, -1/4, 0, 1/2, 1/3, and 2, and go on. The rational number. Also, we have irrational numbers like pi, e, or square root of 2, square root of 3, and go on. Finally, we have what? We have real numbers contain many numbers, infinite numbers. For example, contain pi, -1/2, 0, and go on. Even it's not easy to show it like the set. So we have what? This one is a rational number, and this one is what? Is real numbers. In Kurdish we say ژمارە سروشتیەکان، ژمارە تەواوەکان، ژمارە کەرتیەکان، ڕێژەیەکان، ناڕێژەیەکان، ڕاستیەکان. So these sets, if we can present these sets like a circle. We have the natural number like in the center of the circle. After this one, we have a biggest number. Why? Because if you concentrate on the set of integer numbers, we have a positive and negative and 0. So this part is belong to here. So that's why this is the bigger than. So we have integer numbers. Also, 2 is the rational number. Why? Because the denominator is equal to what? To 1. How about 0? How about -2? They are the same. So these all also belong to here. So we have what? We have rational number. And irrational number is not belong to any of them. Okay? Does not belong to any of them. So together, if you put or we collect these collection with that one separately, if we combine them in the one rectangle, we call as a real numbers. We need the real numbers. Why? Because we're in the especially when in the section 1.5 and 1.6, when we find some results, for example, you say x is equal to something. So here we need the real numbers. So that's why I say the real numbers are like a line which contain infinite numbers from 0 to infinity and here's from 0 to minus infinity. So the real number is the largest set that we have. Why? Because it contains natural number, integer numbers, rational as well, irrational numbers. That's all. So in your lecture notes, you can see we have a small number, integers, and natural and integers, and rational and irrational. All of them together is what you can say. If I put all of them in another set, I will get a real number. Okay, dear. So that's all about the rational and irrational number. Now, as an example about the irrational numbers, you have a lot of example. You can add e. E is another number that we have a section. I think that chapter 4 we are going to talk about e. What's e and how we sketch the graph of e. So in general, in this section, we are going thought you have an information now about what you got some idea about the set of numbers. What's a rational number and what's the difference between them. Now, if you can see, we have two types here. We have decimal. Okay, we have decimal. How we distinguish? If I show you some decimal like this number, for example, 2525525, and go on. Or if I have another number like 325678001, or if I have 52352102991, and go on. So which of these decimal numbers, we recall these numbers as you know, decimal, which one of them belong to the real rational number or irrational number? Which of these numbers they are belong to? Number one is belong to here or there. How about number two? Here or there, and again and again. So the answer is what? Because here we have a repetition, the number is repeated again and again. So we have a 52525252 and go on. So we can write these number as 0.52 with this hat, which means this line, which means that the stress of this number means that repeating this number. Okay, so if we have a repetition or we have finite digits, we recall this one as a digit. So 1 2 3 4 5, and we have a finite digits. So we say these two, both of them, that because we have a repetition or we have a finite numbers, they are belongs to rational number. Okay, dear. So means that we can change this one to the quotients form, to the rational, like that, 1/2 or 1/3. Okay, that means that. So if the decimal is repeated like that or like that or like that or like that, you have a lot of digits repetition. Look, 1 2 3 4 5 6 digits are repeated and repeated and repeated. So these all are belong to what? Belong to the rational number. And if it's the digit is finished, stop it. So we can say also belong to the rational number. But in case it's not finite number, it's going to infinite, we don't know how, and the repetition is not exist, so not repeating. So in that case, only in that case, we see what? We see is belong to what? Belong to the irrational numbers. So one of your question in the Q's, I'm going to give you number, and I say change this one to the decimal. Change this decimal to the rational. So how we do it? For example, if I will give you 0.3333 and go on, you know this is belongs to here. This is the symbol of belongs to rational number, so we symbolize it as a Q. So I say change the decimal into what? Into rational form. When I say rational form, I mean something like that. So in other way, my question is like that, is equal to what over what? Because we say that if it's a repetition, belongs to the rational number. So tell me, what about the fractions? This form is the fraction. Sometimes you say quotients. Okay, so tell me about the number. I should put what over what. So how we change, or how we find the form of these numbers, how we find these numbers, two numbers. This is the numerator, the record, and this one denominator, J record. Okay. So in general, I say what? Because I have 0 point, I say let x be 0.333 and go on. So I will multiply 10 by x. So I get what? If I multiply 10, you know, because why I multiply 10? Because how many digits is repeated? Tell me, how many digits is repeated? Just one. Why? Because just we have 3 repetition. The number 3 is repeated a lot, so that's why the stress over 3. So how about this number? Tell me in your lecture note. We have 2 digits, 1717, so 70, 70, 70. How about this one? Just 6. The other numbers that repeated 1, 2, 3, 4, 5, 6. So 6 digits repeated. So how many digits we repeated? We multiply by the 10. If it's 1, if it's 2, for example, we have 0.58, 58, 58. So I say x is equal to this number, and 100 multiplied 6 is equal to what? Why I say 100? Because I have 2 digits, so I say 2 digits. That's why we multiplied by 10. That's why we multiplied by 100. Maybe next we have multiplied by 1000 or 10,000. Depends on the digits of the repetition or repeated digit. So in that case, if I multiply by 10, you know this 0 is going to like that. Okay, dear. So now we say let, for the solution, x be 0.333. Then we multiply by 10 and we get 0.3. So if I have 10x, which is equal to 3.3333, and I will put x, which is equal to 0.333. Now try to subtract these two numbers. Forget about the above, just for clarifying or for getting the idea. Else I say what? Minus. So 10 minus 1 is equal to 9x. Am I right? 10, we have 10x. Now I have a subtraction between two expressions. So first I have a equality, this side and that side. So I'll say I have a equality. So 10x minus 1x, I get what? I get 9x. Okay, equal. We have equality, okay. Now I'm subtracting, subtracting these number by 0. So I get what? 3 minus 0 is equal to 3. Okay, point. Now 3 minus 3, 0. 3, 3, 0. 3, 3, 0. 0, 0, 0, 0. So it remains what? It remains 9x is equal to 3. Now because I want to find the x, so I say we divide both sides by what? By 3. So I get what? 9 over 3x, 3 over 3x. So finally I get 3x is equal to what? To 1. Now I want to x is equal to what? 1 over 3. So this is my fraction. Okay, so 0.333 is equal to what? Is equal to 1 over 3. What's that? An easy example. So as a first warming up your idea and your ability in math, please try to solve this one and find the result. Okay, that is homework for you. So now I will give you some trick about it. We have 0.3101717. You should multiply by 1000 x 1000x is equal to 317. Okay, 171717, and go on, try to do the last things, the last two steps before. So say 1000 minus 1 and you get what? 99, and you get the idea. Okay, dear? So try to solve please this example. And here's another example for you. Okay, here's another example for you, which say find or repeating decimal, change it to the 3.547. Try to change these numbers into the rational fraction. So you have two homework. First homework is what? About and also you have the solution here as well. So you have 0.31717, change it to the decimal, it's equal to 17495. Okay, also the second homework, 5474747. So also translate or change these, transform this formula into the fraction part. Which number over what? Okay, that's about the first page in your lecture. In the second and the third page, in the third page, we have a lot of properties about how to deal with the real numbers, how we find it, how we find the absolute value, and they are easy if you do it by yourself or by your hands. Please, after watching this video, try to do all these example, or try to resolve it or solve again and again till you get the idea. Otherwise, you can ask me in the Zoom session that you have it Tuesday or any day that you want. Okay. Now, about page 3 in your lecture note that you have it already, we are going to talk about properties of real numbers. They are very easy and simple. The first property you see, commutative, means that addition between a and b, we can change it, as you know, and it's clear in the example. We have what? We say 3 plus 7, we can change it, swap between them, and we say it's equal to 3 by 7. It's easy for you, I know. Also commutative or symmetry in the in the multiplication, AB is equal to BA. How? 3 by 5 is equal to 5 by 3. That you know about this property. Again, we have associative properties, mean that we can play with the brackets, so we can remove this bracket and we manipulate or play with it. We change to this one to be out or inside, and you know it's not easy by talking, it's easier than by example. 2, 4 plus 7, you can say 2 plus 4 and 7. How about the multiplication? Again, so they are the same. you can neglect or ignore the brackets that we have. Okay, again we have what? We have distributive property. Okay, distributive property with a multiplication about this and that. And how we distribute? We can distribute A can come to the brackets, and we can distribute it. So AB, we get AB, and AC, AC. How about the example? If I have 2 multiply 3 by plus 7, 5, we can say 2 by 3 is equal to 6 plus 2 by 5. So first we multiply by the first term, then the second we have addition, the second multiply by the second term. Really, this example is very easy for you, just for recognizing the properties. But in the example, in the exam, in the other examples, they are very important. Look at the example 1, you know what I mean. So how we multiply these two by this? Now we have a x, we have an expression. So 2x plus 3, how we do it? You know, have what? 2, example 1, page 3 in your lecture note. We have 2, part A, x plus 3. So in that case, we say first we multiply here by there, and the second by the second term, and we don't forget about addition we have. So I say 2x, 2 by 3, 6. Okay, directly. How? I say 2 multiply x plus 2 multiply 3. How about the part B? The part B, say if I have 2 brackets, how we deal with this one? It's a little bit advanced from the example A. So as the same, we multiply A by X and A by Y, and we have also addition. Now I say AX, okay, plus, sorry, here's plus, AY, and again we have what? We have another addition. So I'll add again BX, BY. That's all, and easy. Yes, you should leave it. So they say that we use all these distribution and addition and associative and commutative and distributive law. We use it here together. So you don't need to memorize these. Just try to do it by practicing, by solving examples. Now again, you have additional and subtraction properties for real numbers. You know, if we multiply -1 by anything, you get -1, right? If we multiply -1 by A, we get -A. A here means that any number, okay? Without 0, you know. And negative multiply negative is equal to positive. Also, I have what in the third one? Negative by positive. We can say positive by negative, and I get that number. And you will see the application of this property here in the example 2. We will do it together. Also, we can distribute negative to the bracket, to the parentheses. To these brackets. So you say negative by negative A, negative by negative, we get negative. Now I'll do it for you. Here's the example. We have what in the property number 4? Say that if I have negative A plus B is equal to negative A. Now also, sorry for that, also we have negative B. We will do all these together by the example. I think it's easier for you. So I'm going to leave these properties. We will do it by the example. Example 2 in page 4. example 2 in the page number 4. We have minus part A, minus x plus 2 is equal to what? So here's your answer. You say by the property negative by positive, I get negative x, again negative by positive, negative 2, that's all. How about part B? We have negative x plus y minus z is equal to what? You know, is equal to negative x. You can distribute by triple or couple of the numbers or brackets or anything that we have. So negative x, negative y, negative by negative positive z. That's all. Remembering you really this chapter, section 1, 2, 3 is like a revision of your high school till or secondary school till high school, really. So like a revision for you. Maybe some of you bothering because I gave the detail for something that's easier, but these I will give you I will say these or giving these all details because maybe most of the students, they haven't good background or they don't like math because they haven't background. That's why I'm giving you all these details. Now the more important things here is what is the property of real numbers. Okay, the property of real numbers. The property of real numbers here, the page 4, is going to deal with the multiplication and division. And really, here's your problem. You have a problem with the division. So that's why I'm giving you more example here, because later, maybe in 1.4, we have a division part with the mathematics expression. So in there, I am not going to give you a more detail because I say in the 1.1 page 4, I gave you a lot of things here. So please pay attention, and it's very important for you because here's the really the golden idea here. So here we have what? In the first property, see if I have a multiplication, first property, page 4, multiplication and division. So in the first property, say AB multiply CD is equal to, if we have two fractions, we multiply, we say AC over BD without any problem. For example, I have 1 over 2 multiply 5 over 7, I say is equal to 1 by 5. Let me do 3 this one, okay. 3 by 5, we say 15. 2 by 4, 2 by 7 is equal to 14. Okay. How about another example? If I have x over 2, let me say 2 over x for you. My example, what is the rule? E1, E2. So if I have, in case, 2 over 5 multiply x over you say 3. So I say, because I have multiplication, I have two fractions, first and the second. So we multiply this one as an easier. So numerator by numerator, 2 by x, denominator by denominator was equal to 2x 15. That's okay, dear. Good. So now again we are going to the second part. Here's the another part, A over B, another rule, C over D. Also this one is easy. Why? Because we directly say we have A over B and we change the division by the multiplication. So we have a two fractions, divide or division between two fractions, fraction number 1, fraction number 2, and here's the division. So I'll put the first, I'll fix the first, and we change the division to multiplication, and we reverse, okay, we reverse the other fraction. So reverse means that we'll upside down the second. So I get what? I get AD, as you know, by the first, BC. For example, if I say 2 over 3 divided by 5 over 2 or over 4, directly we say is equal to 2 over 3. We change this one to 4 over 5, which is equal to 8 over 15. Okay, another example on the second rule. That's why I'll give you two examples, because really they are important, really very important, because later you need these expression. So now if I have x minus 1 over 2, look, divide by x by 3. So I say, because I have a first part, I'll fix the first part, and we will change to the multiply 3 over x, and finally stuff minus, don't forget, okay, and finally I'll multiply them as a 3x minus 1, 2x. Okay, dear, so they are easy, just need more practice and more example. So please try to do more example, or to try to solve more example about it. Now again we have something else here. Okay, we are another important things here. So rule number 3, that I'm give you more detail about it. Here in the number 3 and number 4, he's talking about addition between two fractions and addition between two fractions again, but they are different. Now I will combine these and I will change it to the another things for you. So here's the new information, or the new distinction between two fractions. In case that you have two fractions, so fraction number 1 minus plus fraction number 2. Okay, so how we add or subtract between two fractions? We have three cases really. Okay,